It's rerouting the feed through the program I used to record. So we're good. At least I'm recording now. And then resistance in series is like the voltage drops. The total resistance of my circuit is equal to the resistance through 1 plus the resistance through 2 plus the resistance through 3, dot, dot. There can be more than 3 things, but we get the idea. You just sum them all together. And then the really kind of gross one was this guy here. The total resistance, in fact, it's 1 over the total resistance, is equal to 1 over the first resistance plus 1 over the second resistance plus 1 over the third resistance, dot, 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 for all of the branches in our circuit. So how is this useful? Well, let's take a look at some circuits and see what we can find. So here's our first example. We want to find, eventually I will just give you a circuit and say find everything. You find whatever you want in whatever order you want, but this is the first example, so things are going to be a little bit easier. This particular example says, what are the values of I1, I2, and I3? Now, I1, I2, and I3, we've got 3 different ammeters set up there. We just want to know what all of those currents are. Before we figure out what they are, what do we know is true about all of them?
They're not on a parallel circuit, not on a single circuit, or whatever it's called.
Which means?
Which just means that the amperage is going to be the same.
Which means they're going to be equal. Cool. So as long as we find it in one spot, I1 is going to equal I2, which is going to equal I3, which is going to equal the total current through my circuit. Now, the goal here is always to simplify the circuit as much as possible, condensing things where we can condense them. So if I have 3 resistors here in series, is that any different than if I had this circuit here? With 1 resistor to replace these 3 series resistors, where the total resistance of that resistor is just 3 plus 4 plus 2. Electrically, it's exactly the same thing.
Yeah,
I can pop out those 3, replace them with one 9 ohm resistor, and now I've got a 12 volt source. I've got a 9 ohm resistor, and I want to figure out what IT is through the circuit. So the relationship between VR and I is what?
V equals IR.
So then I is going to equal V equals IR. I total is going to equal my total voltage divided by my total resistance. My total voltage is 12. My combined total resistance here, because these 3 are all in series, is 9. So I'm going to get a current of 1 1/3, so 1.3 repeating amps. And what we've drawn here, this thing right here, we call that thing the equivalent circuit. The equivalent circuit. Sorry? Jasmine, are you being creepy? So all I've done here is I've applied Kirchhoff's laws, I've applied Ohm's law, and I used them to draw what we call the equivalent circuit to help us find some of this information. Relatively straightforward, yes? Let's crank it up a little bit. I got this one. I want to know what the value of R2 is. R2 is this guy right here. You can try. What do you think that number is going to be? You are wrong. Nice try. Instead of using logical thinking, let's use math.
It'll equal 1 over R minus 1 over R1 minus 1 over R2.
Say that again.
It'll equal 1 over.
What's going to equal? R2
Yeah.
is going to equal,
1 over R total minus 1 over.
so 1 over R2.
Minus 1 over R1. And then minus 1 over R2.
Okay. It's an interesting way to start.
We'll leave the R
I like it.
T first.
We know what R1 and R3 is, but yes, Connor is right. We've got a problem here. We need to know what RT is.
And we get that.
And we get that by doing what? You sound like you had an idea.
Oh, yes, I had a very big question. The voltage and current are things that we do know, so, I'm gonna look back at my notes here.
I'm just going to hide this. No, I'm not going to hide it.
Voltage equals I, which is, or, voltage equals IR, very sorry.
Yep.
So we have a voltage of something, whatever it is. What do you have?
24 volts.
24 volts, thank you. And that will equal our current, which is 1.8 amps.
Yep.
And then we'll just leave R behind, and then we just divide the 1.8 through 24, and it'll give us something, whatever the first person says is the resistance.
What is total voltage?
13.3 repeated.
13.3 repeating
Boom.
equals RT. Cool. So what you've done here is we recognize that we need to find R2. In order to find R2, we need the total voltage. So what would be the resistance if I condensed these three parallel resistors to one resistor, given that the current in the main branch and the voltage is 1.8 and 24 respectively? We went through and we found it. We said, okay, well, total resistance then has to be 13.3 repeating. So now we can go through and actually find out what my R2 is, because 1 over R2 is going to equal 1 over 13.3 repeating minus 1 over 40 minus 1 over 60. So what is that? 1 over R2 is going to equal what value? 0.030303 or 0.33333. Okay. 0.03 repeating. But I don't want 1 over R2, I want R2. So that's going to equal 1 over 0.03 repeating, which is what? It's 30. Again, we use the equivalent circuit to find our total resistance, and then we just use the relationships that we were given before to march through some relatively simple algebra to find our R2.
Do we have to always draw the equivalent circle?
I cannot think of an instance where it won't be useful. So do you have to?
No.
No. But is it a useful tool that I would encourage you to do every time? Yeah. I don't know how, I mean, yes, there are those of you who are going to be able to think this through. For some people, the circuit stuff just clicks, and they like become one with the circuit, and they don't need to draw it all out. But I'm willing to bet none of you are that person, because those people are rare. Manuel might be able to, but that's because he's been doing electronic circuits for a while now, for whatever reason. As a hobby in his spare time. If you are one of those people, then great. But if this is your first, especially if your Science 9 teacher didn't do this stuff, then definitely drawing these equivalent circuits is very, very useful, especially when the circuits that we're dealing with are going to get more and more complicated. I could also then ask you, what is the current? What is, let's just do it. Why not? Instead of saying I could ask you, why don't I ask you? What is I1, I2, I3? What do we know?
In a parallel circuit, I total equals I1 plus I2 plus I3.
Okay, so this is my total current here, that 1.8 amps. This current here is going to be I1, which means the current going this way is going to be what? Is it just I2? It's not, no. I1 went this way. What's going down this branch here?
Oh, I2 and I3.
And this one's I3, which means this one here is I1 plus I2, just so we understand what's happening here. I total splits, sorry, that's a 2 and a 3, not a 1 and a 2. I total here splits into whatever's going to go down branch 2 and 3 and whatever's going to go down branch 1. Here, I2 and 3 are going to split. Some is going to go down through resistor 2, some is going to go down through resistor 3. Cool. Now what? Yes, but if I don't know 1, 2, or 3, that's not as useful. What do we know about branches in a parallel circuit? What's the same? What's the same value? Sorry? The value of what? That's not necessarily. We don't know that for sure. We do know something for sure, but not current. In fact, we know they can't split equally because my resistance is different for each branch. A branch that is harder to flow down is going to have less current flowing down it. A current that's really easy to flow down is going to have more current flowing down it. So we know that the currents aren't going to be equal, but what do we know is equal along the branches in a parallel circuit? Yeah, Eric. The voltage drop has to be. And because there are no other voltage drops earlier or later, each one of these branches has to use the entire 24 volts supplied to it. So we know that V1 is going to be 24. We know that V2 is going to be 24. And we know that V3 is going to be 24. So now how do I go through and find I? We're going to use V equals IR, except it's not V equals IR, it's going to be I equals V over R. I equals V over R. So what's the current going down I1? Sorry? Is it 1.8? I don't know. What's 24 divided by 40? You told me, Jasmine, that it was the voltage divided by the resistance. The voltage is 24, the resistance is 40. Sorry, 0.6? Okay. So then what's I2? Yeah, 24 over 30, which is?
0.8.
So that's going to be 0.8. So then I3 is going to be? Well, there's two ways we could do I3. because we know that I1 plus I2 plus I3 is my I total. But we can also use I equals V over R. So if we were going to sum these things up, 0.6 plus 0.8 is 1.4. So how much current is missing? Another 0.4. What is 24 over 60? 0.4. So it doesn't matter how we do it. We can use I equals V over R, or we can use the fact that the sum of these three currents has to equal my total current. Once we find 2, we can subtract to find the third. Relatively straightforward, yes? Okay, flip page. What do I do with something like this? What is going on here?
Well, it wants to know what the voltage is.
We want to know what is the potential difference supplied by the power source in this circuit. So we're looking for VT. Yeah, Winston, we're looking for VT. So we know total current. We're looking for total voltage. So what do we need to find to allow us to find total voltage? Sorry? I need total resistance. Careful how you do this.
Oh, because it's on a parallel.
Now we've got a combination of resistors in parallel with resistors in series. So what we're going to have to do now is when you're drawing equivalent circuits, we're actually going to have to do this step by step. The first thing we're going to do is we're going to take that parallel piece and figure out what we would have to replace this parallel resistor by. We'll call this RP, the parallel piece for the resistors, to be an equivalent resistance. And then we know this guy here, R1, is 8. So my first equivalent circuit is just going to collapse these two. Well, we know that 1 over RP is going to equal 1 over 24 plus 1 over 12. So that's going to be 1 over 24 plus 2 over 24, which is going to equal 3 over 24, bless you, which means RP is going to be 8. You cool with how that happened? This is more often, you'll more often be given numbers that are a little nicer. Are we cool with RP being 8?
Hang on, I got it.
Okay, where did I lose you?
Yeah.
We cool with what I did here?
Well, no, because I was just seeing 3 over 24,
So then-
and I was thinking that.
Yeah, so then 1 over 24, 1 over 12 is just 2 over 20. I made an equivalent fraction. Same denominator. So then you add the numerators, the denominator stays the same. And I don't want 1 over RP, I want RP. So I took the reciprocal of both sides. I got RP equals 24 over 3, which is 8. So we know that this now is 8 ohms. So then my last equivalent circuit is going to look like this. Where I take these two that are now in series and I combine them into what is now going to be our total. In series, it's easy. Our total is going to be what? One more time. In series, what do I do with the resistances? I add them. So I have an 8 ohm resistor here and an 8 ohm resistor here, which is going to give me a total resistance of 16. And we know that IT is 2. So then what's VT? Well, we know that voltage is just equal to current times resistance. So that's going to be 2 times 16, giving us a total voltage of 32 volts. That's ohms, that's amps. Comments, questions, concerns about anything that just happened? Because we're going to take it further. Why not? How I want to know now everything. What is V1? What is V2? What is V3? And I want to know I1, I2, and I3. What are these values? Are there any ones that you can jump to easily and immediately? If I asked, probably yes. Just because someone could doesn't mean that you could. And I was asking you. Take a look at what we've got here. I'll zoom this thing in so it's easier to focus on. Are there any of these values that jump out right away as being like, oh, yeah, of course that's going to be the same as something we've been given already? Yes, Connor?
Voltage.
What do you mean?
Well, I mean, if you have voltage and you have, you have two combined circuits, but if you have voltage and your first, and we said that for your parallel voltage, everything is equal, so VT.
The branches are equal.
Yeah. So
But we've got a small problem, which is why I asked you to do this. The small problem is this. Resistor 1 is eating up some voltage. So resistor 1 is going to use up some of the voltage. So 32 is not what's going to be available to these two branches. Using the logic that you were developing, Connor, what do you know, though, about V2 and V3? Yeah, these two branches must be equal, but they're not going to be equal to 32 because something else is eating up voltage. So we have to figure out what voltage is getting eaten up by this resistor first. Does anyone see anything that might be useful? Luis, was that a hand? No, sad. Well, can you tell me about the current? Eric. Which ones are equal? Sorry? Two is the one through this branch here. 3 is the one through this branch here. Because these resistors are different, that we don't know that those two are equal. But we do know that 2 and 3 cannot be equal to 1, because 1 is what splits to become 2 and 3. But I heard an O over there, Revneet. Can you tell me what two things are equal first? Then, no. In a second. Total current is the current through the main branch, yes? Are any of these resistors on the main branch? That guy there. What must the current through that resistor be equal to? It's got to be equal to the total current because it's on the main branch. So this guy here, this current and this current are going to be exactly the same. So IT is going to equal I1 because those guys are on the same branch. Ravneet, you can get some water. Knowing that I1 is equal to 2, what does that allow us to find? V1. V equals I times R. So what's V? 1. Come on, guys. 16. Thank you very much. Because V equals I times R. I know R is 8. I know I is 2. So V must be 16. So 16 volts are getting used up by this resistor, which leaves us how much voltage left for these two branches? The other 16. We started with 32. 16 gets eaten up here. And these two must use the same amount. So they're each going to use... No, it doesn't. The voltage doesn't split. Each branch must use all of what's left. Did I hear I'm confused and then an agreement with the confusion? Where did I lose you?
Just like the fact that it doesn't divide, like they both use the same amount of current is where it's confusing.
No, they're not using the same amount of current. They're using the same amount of voltage. I mean, you can think of it like this. If I lift you up 32 meters, you come down 16 meters, you still need to get all the way down to the bottom. Even though there's two paths to take, you have to come down to 0 at the end. Doesn't matter which path you take. One of these paths might be harder than the other to travel, but at the end of the day, both of them must bring you down from where you were, here at 16 volts, down to 0. So you have to, so that's why the voltage, because it's an amount of energy, you have to use up each branch has to be capable of using up all of what's left. It's not like, okay, now you're here 16 meters off the ground, here's an 8 meter one, here's an 8 meter one, and we'll bring you back to ground level. Doesn't work that way. Because they're separate paths, they must each use all of the available energy, which is why each of these is 16, not 8, because voltages don't split. Currents, though, split. Because and the difference is, current is a concrete object actually moving through space. Voltage is a concept of how much energy is present. So it doesn't matter which path the electrons take, they have to use the 16 volts of energy. But some of them are going to go down this one, and some of them are going to go down this one. More of them are going to go down which path? The 12 ohm path or the 24 ohm path? The one with more resistance or the one with less resistance? Less resistance. Lower resistance means higher current. So I can use my relationship before, I equals V over R, to figure out how much current goes through here. I2 is going to equal V2 over R2, which is going to be what? 16 over 12, which is going to be 1.3 repeating. And because we know that current splits, if I had 2 amps going in here and 1.3 goes this way, how much do I have left going down here? What's 2 minus 1.3? Sorry, 0.3 repeating. It's going to be 0.6 repeating. So this is going to be 2 minus 1.3 repeating, which is going to give us 0.6 repeating. And now we found everything. We know the current through every object, we know the voltage in every object, and we're done. No. Can't let you go. Because there's only like 5 minutes left in class.
Okay, we should do a map then.
One more.
No, man. One more.
I want you guys to try this one. Do I want you guys to try this one?
No.
Let's do it together again.
Thank you.
Okay. So, it says what are the values of V1, V2, and R2 in the circuit? V1 is here. V2 is here. And we want R2, which is down here. Anyone want to take a guess at where we might begin?
Sorry, where did V3 go? Oh, it's like,
V3 is here, but I haven't technically asked us to find it yet.
okay. Well, are you?
What about V1? What about R1?
Okay, well,
Want to find it? Okay, well, what is it?
well, maybe we should, let's start with sections out. So we've got the series, and we've got a parallel with two resistors on each.
See, and I think these questions are actually harder to do when I ask you for specific things. So to make our life a little bit easier, what I'm going to do is I'm just going to say, we're going to find everything. I want to know what I1 is. I want to know what I2 is. I want to know what V4 is. I want to know what I3 and V3 are. I want to do it all. And that is actually going to make our lives a little easier, believe it or not. And this was one of the things, this was actually suggested to me by a guy I went to university with. He said, why bother trying to figure out the nitty-gritty details? Just friggin' find, he didn't use the word friggin'. He just said, friggin' find everything, and then go back and look at what the question's actually asking for, and give them the answers. Because often, to find what we're looking for, what we're being told to find, we're going to have to find things that we're not being asked for anyway. The one thing that we can find really easily first is what value? V4. V4 is what? V equals I times R. I is 0.3. R is 20. 0.3 times 20 is 6. Is that you, James? Thank you. Where can we jump very quickly to immediately? V3 is also going to be 6. Thank you, Cohen. Were we asked for V3 or V4? No, but easy to find. Now, I3. Could I find I3 relatively easily now? What is it? I equals V over R. Is it 0.2? Okay. Okay, so now I know I3 and I know I4. And R3, R4, V3, and V4. What can I find really easily now? What do we know is going to happen to these two currents? They're going to combine. They're going to add together to give us this current and which other current? That guy. So I2 and I1 are both going to be what value? 0.5. So that guy's also going to be 0.5, which means V1 is going to be what? Yes, thank you. V equals I times R. I is 0.5, R is 18. So that voltage drop is going to be 9. If that voltage drop is 9 and this voltage drop here is 6, how much voltage does that leave us here for R2? We started with 60. We lost 9 and 6.
Oh, that's 15, so 60 minus 15.
So that's going to give us the 45 volts down here. So what's R2? R equals V over I. Done. So by actually asking you, instead of asking you to find me specific values, if I just tell you to find everything, now you go back and look at the question. What are the values of V1, V2, and R2? Oh, here they are. 9, 45, and 90. And you're done. So let's put some notes in here of some of the stuff that we argued. We said, well, I1 is going to equal I2, and both of those are going to equal I3 plus I4. These two are going to combine here to give me the main branch. We know V3 and V4 have to be equal because the branches in a parallel series, or in a parallel circuit rather, have to be equal to each other. Voltage drop has to be the same down both. And we know for V2, this one we got by saying that my total voltage is the sum of all of my other voltages. So that was 60. We found that to be 9 because V equals I times R plus V2 plus 6. And that was that. So if a question ever asks you for something specific, ignore it. Find everything in the circuit. Find the current down every branch, find the resistance in every object, find the voltage drop in every object, and then go back and read the question and say, okay, what was I actually looking for? It'll make your life a lot easier. So I know there's only a little bit of time left. What I'm going to do, I think it's like 10 minutes left. I'm going to sign a few circuits. 3 minutes left. I'm going to sign a couple circuits that I want you to play with tonight. On Monday, we're going to do a bunch more practice. Because especially for those of you who didn't do this in grade 9, this can take a little while to wrap our heads around, and I got a lot of circuits available for us to practice with. There's 18 questions worth of circuits. I just want you guys to do the first 4. Try the first 4 for Monday. Using the same reasoning that we've been doing here. The math isn't hard. You just got to be able to reason your way through it. I would recommend you use a couple minutes here to actually start some of these things instead of just packing up and doing nothing for the next 3 minutes. Now it's 2 minutes. We'll do more GeoGuessr on Monday.